To begin with, we must look around us and see that the Earth is uneven and has no easily described shape. Even if we ignore houses and other man-made objects and all living things as well, we are still left with an uneven surface of bare rock and soil. The first conclusion we would come to, then, would be that the Earth is a lumpy object with hills and valleys, cliffs and ravines. In places like Colorado, Peru, or Nepal, where there are towering mountains that reach miles into the air, the Earth's irregularity is very clear. But if you live in some parts of Kansas or Uruguay or the Ukraine, you don't see much in the way of hills or valleys. You see plains, which look pretty flat. Then, too, even if you do encounter hills and mountains, the Earth may rise on one side, but then fall again on the other side. Valleys and ravines may slant down on one side, but slope up on the other. No part of the Earth's land surface goes up without ever coming down again as you move across it. No part goes down without ever going back up. It seems reasonable, then, to conclude that the Earth is, on the average, flat. Again, if you were to paddle a boat out onto a body of water so large that you couldn't see land in any direction, you would have only the surface of the water to consider. This surface is uneven because it is full of waves. Yet, if there is no wind, the waves are not large, and it is easy to see that, on the average, the water surface is flat. In fact, water is much more nearly flat at all times than land. So it makes sense to suppose that the Earth is flat, and for thousands of years, that is exactly what human beings believed. Since a flat Earth made sense, and since it didn't take much thinking to see that it made sense, why would anyone waste any further time thinking about it? Have you ever stood on a hilltop and looked out on the valley below? The valley looks pretty flat, and you can look farther and farther outward, past houses, trees, rivers, and other faraway objects, though the more distant they appear to be, the less detail you can make out. What's more, the air isn't usually absolutely clear. Bits of fog and smoke obscure the very distant portion, which becomes a kind of bluish haze where the earth and sky seem to meet. The meeting place of earth and sky is called the horizon, from a Greek word for boundary. If you're looking at a flat section of the Earth, the horizon runs evenly from right to left, and such a line is therefore called horizontal. Suppose, however, that you look in another direction at another hill close by. You can't see past the top of the hill to the other side because you can't see around curves. Therefore, as you look at the top of the hill, you see only the sky above it, and not the earth sloping downward beyond it. There is a sharp line that seems quite close to you that marks off the hill against the sky. Thus, if you are looking out over a stretch of land and see a distant, misty horizon, you know you are looking over some pretty flat territory, but if you see a sharp, nearby horizon, you are looking at a hilltop. Imagine that you are out on the ocean on the deck of a ship. It is a clear, bright, sunny day, and the sea is calm. The sea air is usually less dusty and misty than land air, so you look off into the distance, and there is the horizon, sharp. The sea meets the sky in a clear horizontal line. You are clearly looking at a hilltop.